In this second screencast about trig identities, we're going to look at the double and then the half angle formulas. And those are both derived, all right, the ones for sine and the ones for cosine are, the one for sine I should say, and the multiple ones for cosine are derived from the sum formulas for cosine and sine respectively. All right, we'll start out with the double angle formula for sine, then we'll derive the three double angle formulas for cosine, and then we'll talk about the half angle formulas. Okay, to derive the ones for sine, we're going to, for instance, want to know the sine of 2 theta. What we're going to do is just split that up as a sine of theta plus theta, and then we're going to let u play theta, v play theta up in our sum formula for sine. So we get sine of theta times cosine theta plus sine theta times cosine theta, because u and v are both theta. And therefore we just get two copies of the same term. So that's 2 sine theta cosine theta. And that's it. The double angle formula for cosine is sine of 2 theta is equal to 2 sine theta cosine theta. There's only one double angle formula for the sine function. There's multiple versions of it for cosine. Okay, and so to derive that, we're going to play the same game except with the sum formula for cosine. Alright, so we're going to plug in and say cosine of 2 theta is cosine of theta plus theta. And then again, let u and v, the first and second angles, be the same. So we get cosine, going back up to our top identity, we get cosine of theta squared minus sine of theta squared. And that's one, equating the left with the right hand side, that's one of the double angle formulas for cosine. The other ones we're going to get by just replacing the right hand side, rewriting it using the Pythagorean identity, which says cosine of theta squared plus sine of your angle theta squared is equal to 1. So we're going to solve that, for instance, for sine theta. So you get sine of theta squared is equal to 1 minus cosine of theta squared, and then input that for sine theta squared, and we get that the cosine of 2 theta is equal cosine squared minus 1 minus the quantity 1 minus cosine of theta squared. And then distributing the negative through combining like terms, we get 2 cosine theta squared minus 1. Alright, so a different double angle formula is that cosine of 2 theta is equal to 2 cosine theta squared minus 1. To get the last one, we're just going to do the opposite. Replace the cosine of theta squared in the original by 1 minus sine of theta squared, and then combine like terms. Okay, so we get the following, which gives us, dropping the parentheses here, we don't need these, 1 minus 2 sine of theta squared. Okay. Alright, so that's the last double angle formula for cosine. Okay, next, to get to the half angle formulas, we're going to use the last two we derived. Okay, and separately, we're going to solve for cosine of theta squared in the second to last one. We're going to isolate that particular term. And then, in the second one, we're going to isolate sine of theta squared. Okay, so that's the idea. If you know the double angle formulas, you really do know the half angle formulas. You just need to solve appropriately, okay, and then use them as needed. Okay, so continuing this below, we're just going to bring these identities down and rewrite them. Okay, so cosine of 2 theta, we're going to add the 1 over, okay, to isolate the 2 cosine of theta squared term. Then we'll divide both sides by 2, or multiply both sides by 1/2. Let's flip sides here. Put the term we're going to solve for on the left, everything else on the right. So we divide or multiply both sides by 1/2, and you get 1/2. And I'm going to switch the order of the addition here. This is addition. So we're going to write that as 1 plus cosine of 2 theta. And that's your half angle formula. Or if you want to actually solve, you take the square root of both sides, and you get that the cosine of theta is plus or minus the quantity 1/2 times 1 plus cosine of twice that angle. Okay. To get the other, to get the half angle formula for Sine, we're just going to rewrite the last double angle formula for cosine we determined, and then we're going to isolate the sine of theta squared. Okay, so we'll flip these sides here, add the 2 sine squared theta over, subtract the cosine of 2 theta, and then divide both sides by 2 or multiply both sides by 1/2 to get that sine of theta squared is equal 1/2 times 1 minus cosine of 2 theta. So the formulas look pretty similar, except you got one. The first one you get the plus sign, the second one you get the minus sign. Again, if you want to solve for sine of theta, you take the square root of both sides and you get plus or minus the quantity on the right. Okay, so those are our half angle formulas. Okay, sometimes it's going to be convenient to use it leaving it squared. Sometimes it'll be convenient to actually solve for it. Let's do one example where you actually want to apply all these formulas, and we're going to do this to compute exact formulas, exact form answers, exact form expressions for cosine of 15 degrees and sine of 15 degrees. To do that, we're going to use the last two half angle formulas, okay, where we've isolated cosine and sine. Theta, we're going to let be 15 degrees, and therefore double that. 2 theta is going to be 30 degrees, which is a known value. We know the values of sine and cosine at 30 degrees. So plug into the first one, we get cosine of 15 degrees is equal plus, not plus or minus, we know that's a positive number, 1/2, the square root of 1/2 times 1 plus cosine of 30 degrees. Now we know that value's square root 3/2. Okay, so we can put that in here. And then we're just going to rewrite, distribute the 1/2 through the parentheses. We'll get 1/2 plus the square root of 3/4. Okay, then we can combine like terms. All right, just add these fractions together, multiply top and bottom by 2. Okay, and then we're going to apply the square root property. So we'd have 2 plus the square root of 3 on top, divided by 4, all into the radical. Take the square root of the top and bottom, and we get that quantity. All right, so it's kind of a funny looking expression. We got a square root inside of a square root, but an exact form expression for cosine of 15 degrees is that square root of 2 plus the square root of 3 all over 2. We can do a very similar thing to compute the sine of 15 degrees. Right? Plugging into the half angle formula, you get positive square root of 1/2 times 1 minus cosine of 30 degrees. We know that value, square root of 3/2, so you can input that. Okay. Distribute the 1/2 through the parentheses. We're going to get 1/2 minus square root of 3/4. Multiply top and bottom by 2 to get common denominator. Then add them together. We get the square root of 2 minus square root of 3 all over 4 under our square root. Take the square root of the top and the bottom, and we get our exact form expression of the sine of 15 degrees. Again, it's a very strange looking thing. You don't often see a square root inside of a square root, but that just goes to show you that these values are not so simple computing them by hand.